Hey, what's up? We're going to talk about how we can use Desmos and graphing to solve systems of equations. So today, systems of equations by graphing. All right, so here we go. We have our example A. Pre-orders for the yearbook cost $38 each. The full price costs $45 each. If 24 students in Mr. Hillman's homeroom purchased yearbooks for a total of $975, how many students pre-ordered X and how many students bought their yearbook at full price Y? All right, so we have our system, 38x plus 45y equals 975. That's how we get the money, right? And then x plus y, pre-orders plus full price, equals 24 students altogether. So when we want to graph in Desmos, the first thing that we need to do is convert our equations into slope-intercept form. Because when we are in Desmos, we can't do anything except y equals, all right? So we're going to convert. Here we go. We want to get y alone. We want to isolate y. So we're going to zero out x, or whatever I do to one side, I always do it to the other side right away. So I end up with 45y equals negative 38x plus 975. And then you divide by the coefficient of y. For today, because I'm not going to hand graph, I'm going to use Desmos, I'm actually just going to leave my fraction like this. Okay, because we'll see that like I could simplify it because that would give me true slope-intercept form, all the way simplified. But right now, I'm going to be using a tool to help me with the graphing part, so I can leave it like this. The big thing is to get it as y equals something on the other side. All right, so let's look at the other one, x plus y equals 24. Zero out x. So y equals negative x plus 24. I'm already at 1y equals, so I'm done with that equation, okay? So then what we do from this point is we're going to follow these directions right down here, okay? So we're going to type the converted equation into Desmos. We're going to click on the lines and we're going to find the point of intersection, okay? Because where they intersect is the solution to both equations, and the solution to both equations is the solution to a system. Remember, systems make equations true, okay? It tells us that that point actually is on that line. It's part of that data set. So we're going to jump into Desmos real quick and look at what this looks like. Okay, so I typed my equations into Desmos. Okay, slope-intercept form. If I look at my graph, I don't see it, so I might have to zoom out, and you just need to go till you see it. Okay, if you don't see any dots on your lines, you just click on one of the lines and it'll show up. What we're looking for is this intersection, okay? This point, if I kept zooming in, zooming in, zooming in, this is where my two equations cross each other. That point of intersection is my solution. So 15,9 is the solution to this system. 15,9, okay? But this is a story, so I have to see, like, what does that actually mean? So this is X and this is Y. So I tell myself what this means, okay? So this means that 15 students pre-ordered and 9 is Y, which is the full price. So 9 students paid full price. And so that's what we're doing today, is taking our system and going and finding, okay, well, where do they intersect? What is that solution? And what does it tell me about my story? So we just found out how many students pre-ordered and how many paid full price, okay? So let's do it again. Second example, the Boy Scouts are selling popcorn at the parade to raise money for their camping trip. Ethan sold 9 small bags and 2 large bags and made $36.05. Jack sold 5 small bags and 7 large bags and made $48. Find the cost of a small and large bag of popcorn. Okay, so we have our system over here on the left. We know that X represents the cost of the small bag and Y represents the cost of the large bag. All right, first thing we're going to do, these aren't, neither one of the equations is Y equals, so we have to convert it. So my first equation, 0 out X and then divide by the coefficient of Y. We divide everything by that coefficient. All right, so there's one conversion, and we do the same thing to the other side. So I have 5x plus 7y equals 48, 0 out x is 7y equals negative 5x plus 48. Remember, you can't combine those because they're not like terms. Divide by the coefficient, because our goal is to get y equals 1, y equals something on the other side. Okay, once we have the conversions, we hop over to Desmos. We're going to type them in, click on the lines, and find the point of intersection. Okay, so I'm going to hop over here. I'm going to go ahead, clear out my equations, and I'm going to type in my new one. So y equals, I'm going to do the fraction bar up front. Okay, 9x plus 36.05, arrow down, divided by 2. There's one equation. Then I have y equals fraction bar, negative 5x plus 48, arrow down, over 7. Okay, again, I don't see it on my, notice I clicked the home button over here, and hey, there it is. If I want to see a little bit more, I could do this. Okay, notice when I did that, my dots disappeared. Just click on a line again. There they are, and find that point of intersection. That's the solution. That's going to tell me what x and y equal in this story. Okay, so I come back over here to my notes, and let's write down what our solution is and what it means. So we had x is 2.95 and y is 4.75. And this is why knowing what your variables are matters, because then you can tell me what it means. So each small bag, because x is the cost of the small bags, each small bag costs $2.95. Each large bag costs $4.75. So now we know. Now it's no longer a mystery because we had two equations that are working together that allow me to find the information that's missing. That is the only point they have in common. That's how I know that the small bag is $2.95 and the large bag is $4.75. So convert, hop into Desmos, find your point of intersection, and then look at your story to know, well, what do those x and y values actually represent?